move this into presentation mode so we don't get any background noise.
Only the host can talk now.
Okay. We'll get started here in just a second. All right, it's magic time, so let's begin. First off, I'd like to start off today by saying hello. My name is Lance Zurich, and I am the product manager for the fischertechnik division over here at Studica. And in today's webinar, I'm going to provide you with an overview of fischertechnik robotics. Now, this presentation is going to look at both the line of fischertechnik education construction sets that are used for exploring different aspects of robotics, things such as electropneumatics and IoT, as well as the line of pre-assembled simulation models that are used for vocational training, higher education, and demonstrating various industrial processes. So, hang on a second here. So the question, what is fischertechnik? Well, just to provide you with a very brief introduction, fischertechnik is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, fischertechnik was created with more of an engineering mindset. And what I mean by that is that the core building block used in the fischertechnik system is unique because it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place, and the hundreds of different parts available will also help you to address very specific design needs. Now, fischertechnik was originally created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, Mr. Fischer, at the time of his death back in 2016, held more patents in his name than Thomas Alva Edison did during his lifetime. Now, besides fischertechnik, Mr. Fischer was the inventor of synchronized flash photography, which was back in 1949, and he was also the creator of the expanding nylon wall plug, which is often used in conjunction with a screw or bolt to anchor heavy objects to walls. Now, his company, the Fischer Group, employs thousands of people worldwide, producing many variations of fastening devices used in building construction, as well as numerous components used in the automobile manufacturing process. And they also provide consulting services in regards to various state-of-the-art manufacturing processes. Now, at this point, I'd also like to point out that fischertechnik was the very first construction set of all the construction sets out there, and you know the names. It was the very first of the sets to offer students the ability to build and program their own robots, and that's using the original pre-Macintosh era Apple computers. Now, almost since its inception, fischertechnik has been used by middle schools, high schools, colleges, and universities all around the globe to explore STEM-related concepts. And this is going to be things like robotics, as we're covering today, renewable energy, mechanics, pneumatics, and so on. Now, fischertechnik has also been used by numerous companies like Porsche, Daimler Chrysler, and BMW, just to name drop a few, for industrial simulation and training purposes. Now, recently, we've also seen many of the top companies at the cutting edge of IoT development, developing applications, for example, used in the IoT process. And of course, for those of you who don't know, IoT refers to Internet of Things. Well, we've had many of these companies using the same simulation and training models to demonstrate and study various IoT-related processes. Now, with all this in mind, more than being just something that students are only going to use for a year or two in their development, fischertechnik is really designed so that students can grow along with it. So basically, as students progress through their academic careers, they can also progress through the levels of fischertechnik education solutions which are available. Now, fischertechnik education products are designed to offer a progression. Now, at the elementary level, specifically grades 2 through 5, there are curriculum-based options for introducing brief achievable activities based around simple machines, as well as introductory robotics and coding. Now, when we get to the middle and high school level, there are sets for performing different STEM-related activities around a progression of subject-specific models, which can easily be inserted into class as needed, or more extensive standards-focused curriculum sets are also available for offering a complete and fully integrated project-based STEM experience as basically a class unto itself. Now, for college classes focused on things like robotics and automation, or for vocational and technical schools, there are, of course, that series of pre-assembled industrial simulation and training models that I touched on before. Now, while the subject matter may become more advanced and sophisticated, the same building system and the same parts are used throughout all levels of fischertechnik solutions. Now, here you will see a list of the various product lines that fall under the banner of fischertechnik education in order of how they appear in this progression that I just mentioned. Now, for our purposes in this particular presentation, we will focus on the two areas that you now see highlighted in red: the line of fischertechnik robotics-focused construction sets and the line of pre-assembled simulation and training models. I will point out that we have two other sets that also focus on robotics, which will not be covered in a lot of depth here, as they are also the subject of their own webinars. These two sets that I'm referring to are the STEM engineering set and the robotics competition set. Now, I will touch on how these two sets differ from the other items briefly at the end of the presentation, but once again, they'll be covered in more depth in their own webinars if you'd like to sign up for those. That all being said, let's begin our exploration of the fischertechnik education robotics line. Now, on your screen, you see a list of the products in this line. And of course, that's the Robotics Minibots, BT Beginner, the Robotics Advanced, Robotics TXT Controller, the ROBO Pro Software, a set focusing on robotics and electro-pneumatics, another set focusing on robotics and industry, the Robotics Sensor Station IoT, of course, Internet of Things, and the 3D printer set. Now, this slide shows in boldface red type the 6 construction sets found in the line that I just mentioned. Now, each of these sets, of course, focuses on a specific area of robotics, such as, of course, robotics and industry, or on a particular age range, such as the Minibots, which is intended specifically for younger students. And each of these sets includes instructions for building a specific progression of models related to that area. Now, please note that these sets that we're discussing that are featured on this slide, while all educational in nature, do not contain formatted curriculum per se. Instead, each set contains either printed teaching and activity materials, or it provides access to downloadable versions of such materials. Now, this material is designed to provide teachers with suggestions for various experiments and tasks that students can perform with each finished model in class. The items I'm going to highlight over here, the Robotics TXT Controller, shown in red first off, is the interface or controller unit used for all of the upper level robotics sets. And the ROBO Pro Software, also shown in red, is the graphic programming software which is used for all of the fischertechnik robotic models. Now, I want to mention that while this ROBO Pro Software and the TXT Controller are included in the Robotics Advanced set, which of course we're going to discuss, they are not included in either the Robotics and Electro-Pneumatics set or the Robotics and Industry set. Now, they can instead of course, be purchased separately if you don't already have them. And I should also mention that each of these three sets, the Robotics TXT Advanced, the Robotics and Industry, and the Robotics and Electro-Pneumatics set, will also require either a fischertechnik AccuSet or a power set to power each of the models built. Now, this required AccuSet or power set, which is used for stationary models, are each sold separately as well. The robotic sensor station set, which is going to be available in 2 versions, one which includes the required software controller and power supply, and one without. Of course, we'll discuss all those items later. The first 2 sets on the list, the Minibots and the BT Beginner set, will not require the purchase of any additional software controllers. That being said, each is powered by common 9-volt batteries, which are also not included. Now, as with the fischertechnik STEM Fundamentals line, which is the subject for their own webinar presentation, the sets in the fischertechnik robotic line are designed so they can be used in middle or high school settings, but there's no reason that they can't also be used in a college class as well when exploring these topics. Now, each set comes packed in a sturdy plastic gratinol storage box, and each includes a printed, full-color, step-by-step pictorial assembly manual for building all of the models being addressed in that particular kit, as well as additional teaching and activity materials either in printed format or, as I mentioned before, available for download from the fischertechnik e-learning portal. Now, the first set we're going to look at today, and it's the first set in the robotics line, is the Minibot set. Now, this set includes 145 parts for building 5 different mobile models. Now, this set provides an engaging pathway for introducing students age 8 and up to the world of robotics. The models are all powered by an everyday 9-volt block battery. And while the battery is not included in this set, everything else you need is. No PC is required. The models here utilize a special pre-programmed robotics module. Students select the different programs on the module by using a series of 5 sliding switches, and this is also known as a dip switch or DIP switch. Each switch is either placed in an up or down position to select from the various programs. One of these programs also allows students to create a short motion program by using 2 buttons and the Teach-In mobile robot. First off in this set, students will learn about actuators, a component that performs some type of action such as an XS motor, and they also learn about sensors, which do not perform an action per se, but instead react to situations and events such as a push-button switch and the infrared trail sensor. The first robot students will build is a basic mobile robot. Students can control the speed and direction of the robot by using a potentiometer, which is located on the robotic module. Next, students build a hindrance detector. This robot is constructed with two of the mini push-button switches acting as sensors. Now, when this robot bumps into an obstacle, for example, it encounters in its path, it will back up and deviate from the path of the obstacle. Now, again, the direction of the deviation can be controlled through the use of the potentiometer. The third model to be built with this set is a trail sensor, which combines some of the attributes of the previous models with an infrared trail sensor. This enables the robot to follow a trail in the form of a black line, which is either as found on the pre-printed obstacle course included with each set, or a black line or path of at least 20 millimeters wide, which students may, of course, create on their own using a magic marker or what have you. The fourth model in the set combines the hindrance detector with the trail sensor. Now, with this variation, the trail sensor reacts to a black line it encounters as if it was an obstacle to avoid. The fifth and final model with this set allows students to build a Teach-In robot. Now, Teach-In is a concept that comes from the world of robotics where a robot is moved to a series of desired positions, which are each saved in a program, so that these same movements can be repeated easily in the future. Now, students here will learn how to run this Teach-In created program either on a one-time basis or how to run it in an endless loop. And that essentially is an overview of the Robotics Minibot set, and as you see here, pricing on this set starts at just $142 per set. The next set in the fischertechnik Robotics line is the Robotics BT Beginner Set. Now, the BT in the name refers to the ability to the ability to control the models via Bluetooth. This set contains 380 parts for building 12 real-world models, and it offers an ideal introduction to instrumentation and control for students age 8 and above. Students start off with an overview of the components they will be working with. They begin by learning about actuators, such as the LED module and the XS motor, before moving on to a brief overview of the sensors found in this set, specifically push-button switches and the phototransistor. Students learn about the different types of circuits that can be made with the push-button switch. Next, students are provided with an overview of the BT Smart Controller. They learn about the 4 inputs for connecting sensors, 2 outputs for connecting actuators, power connections for either a 9-volt power adapter or a 9-volt battery, and the ability to connect to the computer or tablet hosting the programming software either via USB connection or by Bluetooth 4.0 system, or by Bluetooth 4.0, System requirements are either a computer using Windows 7, 8, or 10, or you can also use an Android tablet or smartphone equipped with Android 5.0 or higher. Now, selected Bluetooth 4.0 sticks are also required for Windows 7 machines. The BT controller, I should also mention, is compatible with Scratch. Now, users are walked through the various methods of Bluetooth connection. They're walked through the installation of ROBO Pro LT programming software or the ROBO Pro Smart app for Android devices. Next, students are given an overview of the ROBO Pro LT software. They learn about the logic symbols or elements used to create and control their programs, as well as how the program work environment is laid out. For example, the toolbar, the working screen, the test window, and so on. Students begin to explore the actual programming with the merry-go-round model. Using this model, students learn the basics of working with graphical programming software. They learn what a control program is, how elements are added to a program and connected to one another. They learn about adding time delays and modifying actions, such as direction of rotation. They learn how a program is designed to start and stop, how it can be looped, and how a program can be expanded. Students explore further variables in programming with the building and control of a pedestrian light simulation. Here, students work with various settings, such as the sequence of phases, and the brightness of the traffic lights. The next model constructed, that being a model of a lighthouse with a blinking light, allows students to explore the programming to address the three principles of lighthouse lighting. Now, lighthouse lighting, this would refer to the isophase principle, where the beacon is programmed so the length of the light and dark phases are of an equal duration. The flash principle, where the light phase duration is programmed to be only a fraction of the duration of the dark phase. And the blink principle, where the two lights on the beacon are programmed to be illuminated for a different period of time, independent of each other. The refrigerator door simulation offers further programming challenges. Here, students will have to first program the light to go on when the door is open, and then to modify this program to cause a red indicator light to start flashing when the door remains open for a specified period of time. The next simulation students build is a drum-style washing machine model. Now here, students will work with programming different cycles, with variations in time, variations in speed, and direction of rotation. They'll program a safety switch for the door, and also program the text display to show the current cycle. An automated hand dryer is addressed next, which is programmed so that when a light barrier is broken, a fan switches on and remains on until the light barrier is no longer interrupted. The exploration of the use of light barriers continues with the construction and programming of a parking barrier that raises to allow vehicles to pass when a light barrier is broken. Students will next build a trio of industrial simulation models. The first model, that of a punching machine, requires students to program a safety switch, where the machine will only operate when two switches are held down simultaneously, along with the light barrier. The second of the industrial models to be addressed is the conveyor belt. Students program the belt to activate when the first of two light barriers is interrupted or broken, and to switch off when the second light barrier is breached. The final industrial simulation combines the functions of the previous two models. In this case, students will program the conveyor belt with punching machine to move a workpiece down the belt to be punched, and then reverse direction and move the workpiece back to the starting position. The final two models introduce students to mobile robotics. First, students build a tracked vehicle, which sometimes requires them to reprogram the motors that move the tracks on each side to run at different speeds so that the vehicle will move in different directions. Students program various direction changes with different motion times. The final model to be built adds a hindrance or obstacle detector to the tracked vehicle. Students are asked to build some simple obstacle courses out of materials they have on hand, and then to program the robot to recognize and drive around these obstacles. The instructional material also includes a special section specifically on programming and controlling the various models using the downloadable ROBO Pro Smart app on Android-based smartphones and tablets, and the Bluetooth feature. And that's an overview of the Robotics BT Beginner Set, once again containing 380 pieces in all, including the BT Smart Controller and the ROBO Pro Lite software. Once again, for building 12 different models, and your starting price on this set is just $225 per set, and of course, quantity discount pricing is available on that. Now, we're next going to step up to the main tier of the fischertechnik robotics line, and we're going to begin that by looking at the Robotics TXT Advanced Set. This set contains 310 parts in all, and it includes the Robotics TXT Controller. It also includes the license of the full ROBO Pro programming software, and all of it once again comes packed in a handy, sturdy plastic Gratno storage box. Now, regarding the TXT controller, which you see on your screen now, it's the latest and greatest controller yet created for fischertechnik robotic models. It boosts a full-color 2.4-inch touchscreen display, combined WLAN, aka wireless local area network Bluetooth module, a micro SD card slot for additional memory space, an IR receiver diode, an integrated loudspeaker. It also has 4 motor outputs, 8 digital analog inputs for sensors, and 4 high-speed numerical inputs. Now, the TXT controller has 128 megabytes RAM, 64 megabytes flash memory, and a 600 megahertz processor. The Robotics TXT controller, of course, may also be purchased separately as part number 522429, which you can find on our site. Now, the ROBO Pro software is, again, the full version of the programming software that is used for all of the advanced fischertechnik robotics models, as well as the 9-volt versions of the industrial simulation models, which we're going to touch on later in the presentation. Now, ROBO Pro is a graphic programming software which uses easily identifiable icons and a flowchart style design, and it helps to make programming easy to understand even for the novice. Now, it should also be mentioned that the software includes sample programs for all of the models that are going to be built with this set. Now, with the aid of the ROBO Pro software, it's also possible to program your own apps for controlling the models with your Android smartphone or tablet PC. Now, students can visit the manufacturer's website for more information on this, as well as the fischertechnik e-learning portal, once again using the access code that's included in the assembly instructions. Now, ROBO Pro software is also available for purchase separately in both single-user and site licenses, and you can also find that on our websites. The contents of this set, combined with the fischertechnik AccuSet for powering the models, which, as I mentioned before, is sold separately, will allow students to build 14 realistic models, including mobile robots and robots incorporating vision systems. Now, the latter is made possible with the addition of the fischertechnik USB camera attachment, which is also included inside the set. Students will start off by learning about the different components that are going to be used in constructing the robots. They first learn about actuators, and those are the components which perform some type of action. And some of the examples of actuators found in this set include the encoder motors, the excess motor, the LEDs, and the lens tip lamp. After this, students will examine the sensors to be used. And the sensors, of course, act as the counterpoint to the actuators. This is because they do not perform any actions, but instead react to certain situations or certain events. Now, examples of sensors found in this set include the phototransistor or light sensor, the push-button touch switches, an NTC resistor, which is also a heat sensor, and the previously discussed camera module. Students first progress through a series of starter models to become familiar with the TXT controller and the software. The models include a simple ventilating fan, a timed pedestrian light simulation, a hand dryer equipped with a light barrier, a temperature control where once a specific temperature value is exceeded, the fan is turned on, and an automated barrier, once again using a light barrier that must be interrupted for the bar arm to raise. After this, students will begin to explore and use the camera and image processing with robots. The first model of the cameraman introduces students to how they can view what the robot camera sees on their own computers using, of course, the ROBO Pro software. They can also turn the cameraman into a motion detector and learn how intense a motion must be to activate the sensor or actuate the sensor, and how extensive the motion must be in relation to the entire sensor field for the robot to react with a flashing alarm. They will work further on this idea with the next model, that of a swiveling security camera, where a motion can be made to trigger an alarm which will sound through the loudspeaker of the TXT controller. Students begin to explore the area of mobile robotics by first building a basic mobile robot. They will learn about how turns and changes in direction can be programmed in. They will learn how the use of standard motors can yield imprecise results and how greater precision and movement can be achieved with the use of the encoder motors. With encoder motors, the rotation of the motor is measured with the use of a magnet and a sensor, much as a bike speedometer clocks the revolution of the bike wheel. Next, students will create a mobile obstacle or hindrance detector. The robot will be programmed to back away from obstacles it may encounter, move around them, and then resume on its journey. Students will modify this model with the addition of the USB camera module to create a robot that can react to color, and also share what it sees as it moves around the world. As with the use of the wireless connection between the TXT controller and the PC, students will also be able to control the robot remotely. The next model the students will build and experiment with is a trail sensor or a trail searcher that uses the camera to detect and follow the path. This can allow for even greater precision in reacting to changes ahead, such as curves in the pathway. The detection robot combines several camera functions in one model. This robot is able to look forward to detect its surroundings and is also able to look down to follow one of various colored trails on an obstacle course. It also uses the NTC resistor to collect temperature data. Students can also download the TXT CamDroid app from the Google Play Store. This app allows them to connect the TXT controller to their Android smartphone via wireless, which enables them to remotely control the detection robot. For the final exercises, students will build two variations of a soccer playing robot. The first variation includes movement control, where the camera is mounted on a stand next to the robot, and the robot is taught various tricks, such as how to shoot a ball once it is detected by the light barrier, or how to react to various movements made in front of the camera. For the second and final variation, the camera module is installed directly on the soccer robot. This robot uses a printed stadium simulation, which is also included in the box. Students then go about various programming tasks to enable the robot to properly detect the ball and various markings of the stadium. By recognizing these markings, the robot is then able to properly position itself on the playing field with a higher degree of accuracy. Now, all 14 models just discussed can be built with the Robotics Advanced set, which includes, again, the TXT controller and the ROBO Pro Software. And again, the use of a fischertechnik AccuSet, which is sold separately, will be required. And once again, here you see that the pricing on this set starts at just $540 per set, including everything except the AccuSet. And of course, if you contact us, quality discount pricing is, of course, available for schools, classrooms, etc. Now, the next two sets which we'll review each contain parts for building specific types of robotic models, and are essentially designed as add-ons to the Robotics Advanced set which we just explored. Now, each of these add-on sets will require users to have a Robotics TXT controller, which of course I mentioned. It'll require you to have the ROBO Pro software, and it will also require you to either have the AccuSet or a fischertechnik power set for all models and activities to be performed. Now, the first of the two sets that I'm discussing that we're going to look at is the Robotics and Electro-Pneumatics set. This particular set contains 440 components, which when combined with the items I just mentioned, will allow you to build 4 different electro-pneumatic machines and robots. The instructional material that accompanies this set begins with an overview of the principles behind pneumatics, which of course is the process of producing motion with air. Students learn how a pneumatic cylinder works, how pressure is calculated, and the process of generating and storing compressed air with the use of a compressor. Students then learn about using valves, such as solenoid valves, to control the flow of air to the pneumatic cylinders so that the cylinder either expands or retracts. They also learn about how electrical and pneumatic circuits can interact. Now, the first model addressed in the progression is a compressed air motor that acts in a manner similar to a steam engine, except that in this case, instead of steam serving as the propellant, it is compressed air. Students then experiment with different methods of controlling the model. For example, manual control with the use of a push button, then in incorporating a switching plate for continuous motion. Next, the model is wired to the ROBO TXT Controller, and students can then explore how a program can be used to control the model. The second model is a simulation of a color sorting machine, such as you might find in an industrial setting. This model incorporates a vacuum suction device for gripping workpieces to move them about. It also incorporates an optical color sensor, which is used to sort the various parts by measuring the reflected light from each piece, which is output is a voltage between 0 volts and 10 volts. As each color is assigned its own approximate voltage, the sensor thus helps the machine to sort the parts by where each piece falls in the voltage range. Students learn how to define these color values. Students learn about the various sensors and actuators introduced in this model, including the use of a phototransistor and a lens tip lamp, which are used together to form a light barrier. They also learn about the electric motor and the vacuum pump, as well as how the control program and color recognition subprogram required for this model are created in ROBO Pro. The next model, a ball obstacle course, utilizes a vacuum picker arm to automatically return balls to the starting position. The importance of accuracy of construction and attention to detail when wiring are stressed. Students perform further work with subprograms and learn about defining variables in a program. Now, the final project addressed in this set is the building of a pinball machine simulation. And this pulls together all of the elements touched upon previously in one highly sophisticated and, I might even say, very cool model. And that's an overview of the robotics and electro-pneumatics set. And once again, this set, the pricing starts at just $240 per set. It does require those other items I mentioned before. The next set is the robotics and industry set, which, like the previous set, of course, allows you to build 4 different models, this time, of course, focusing on simulations of the type of model robots you might see or might encounter in an industrial setting. The set itself contains 510 parts, which includes aluminum struts for greater stability of the models. The teaching and activity PDF that accompanies this set begins with a brief overview of industrial robotics, the origin of industrial robots, created back in 1954 by George DeVol, as you'll see up on the screen, and the many areas of production where such robots are used, such as welding, cutting, measuring, grinding, stacking, assembling, and so on. Now, as in the previously discussed set, an overview of the materials that will be used is provided, including the actuators, the sensors, the controller, and the ROBO Pro software. The first model to be addressed in this set is a gripper robot, which is designed to be able to raise and lower its arm and also to be able to turn. Robotic positioning is discussed and specifying the position of the linear and rotary axis of the robot. Students are asked to create a reference run program and a flowchart. They will also revise portions of this program. The second model built is a high bay storage rack, as is commonly found in many modern warehouse systems. Now, as the positioning needs become more sophisticated here, more subtasks are required in the programming, each of which requires a subroutine to be created in the robotics program. A sliding control is later added for convenience of control. The third model addressed is a pivoting gripper, which allows you to create a robotic arm which can position work pieces at a different angle than they were originally picked up at. Further positioning subroutines must be created by the students for this new pivoting action, building on the programming steps they've learned about in the previous models. The final model is that of a 3-axis industrial robot, with a robotic gripper which can move in 3 different directions. Now, while the previous 3 models built were designed for very specific activities, the 3-axis robot, by contrast, is more of a multifunction robot, which can be used to perform various types of work. With the 3-axis robot, students learn about the teach-in method used for programming industrial robots. Again, this is where the robot is moved to a specific position using the controller, and the position is learned or saved, and then moved to the next position, which is also saved, and so on and so forth. Now, this sequence of saved positions together form a program consisting of all of these various motions, which the robot can later perform by itself. Students will create their own teach-in program using this robot. Students will also learn about French mathematician Edouard Lucas and the puzzle he created in 1883 called Towers of Hanoi, which involves the moving of plates or workpieces in a specific arrangement. They then use the 3-axis robot to help solve this puzzle. And that's the Robotics and Industry set. Again, like the Robotics and Electro-Pneumatics set, a TXT Controller, the ROBO Pro Software, and either a fischertechnik AccuSet or power set will be required for all operations. As you see here, pricing on this set starts at $270 per set, and again, quantity discount pricing is available. The next set in our progression, or the next 2 sets, I should say, in our progression, are the 2 most recent additions to the fischertechnik robotics line. Now, these are 2 variations on the Robotic Sensor Station IoT, which is available both as a complete set, which includes the controller, the software, the power supply, everything you need. And there's also a version which, like the Robotics and Industry and Robotics and Electro-Pneumatics set we've just discussed, where these items must be purchased separately. In either case, the focus of this set is to provide students with an introduction to data logging, as well as cloud-based control, smart homes, and the Internet of Things, also known as IoT. The downloadable teaching materials designed for this set begin with an exploration of some of the key terms, or I should say an explanation of some of the key terms. Digitization is discussed first, beginning with the roots of the term, which date back to the original computing machines created by Gottfried Leibniz in the 17th century. Essentially, the term once referred primarily to the conversion of analog data into zeros and ones. Now, the more modern use of this term refers to the storage and processing of data without using paper, such as the conversion of printed books into e-books or of music saved as MP3 files. Now, the term Internet of Things refers to the global networking of real and or virtual objects using computers located around the world, which allows these real or virtual objects to exchange information with one another. The term smart home, also sometimes known as efficient living, refers to the networking of household appliances and such, things like heating systems, lamps, washing machines, and so on, so that they can be monitored and controlled from a central point. Finally, the term Industry 4.0 is discussed, which is somewhat similar to the idea of the smart home. Here, the process of producing specialized goods that meet a customer's particular criteria can be completely automated, even up to the point of preparing these goods for actual shipment, an instance where the first actual human to interact with these goods might be the person actually involved in delivering them to the end user. After this, we begin a discussion of some of the components included and suggested work habits, similar to how these were addressed in the previous sets we've reviewed here. The first activities with this set will center around a simple model of a light with a brightness sensor. The idea here being that such a light could be used outdoors, and the light itself controlled depending on the level of ambient brightness. Now, this is a great activity for enabling students to become familiar with the use of the Robotics TXT Controller, and it's designed to take students step by step through the act of creating a program for the model using the ROBO Pro software. First, students will need to create a program for the robot where, as it becomes darker, the lights turn on. Now, doing so will require students to experiment to determine a threshold value, meaning a resistance value be registered by the photo transistor, which will in turn cause the light to go on or turn off when a lower value is registered. Now, once students have created a successful version of the program utilizing these resistance values, they will then be asked to create a program where the three different lights on the model, as you see in the picture, will switch on one after another as it becomes increasingly darker until all three bulbs are illuminated when it is completely dark. Yep. The next model built will be a noise sensor. Now here, students will utilize a sensor built into the circuit board of the included USB camera attachment. Now with this model, students will be required to create a program that continuously measures the noise level. And as different decibel levels are reached, different indicator lights, in this case either green, yellow, or red, will need to be illuminated on the model. Designing this program will require students to utilize a subroutine. The next model will replace the USB attachment with an environmental sensor, an all-new fischertechnik component unique to this set, and this will allow them to create a robotic wellness sensor. The new environmental sensor will enable the robotic model to be able to measure such variables as gas, atmospheric pressure, humidity, and air temperature. Here, students will incorporate a special block in their programming containing both an init and a get block. Three different programming projects will be addressed with this model. The first involves the creation of a frost monitor. Here, the ambient temperature is to be continuously monitored. If the temperature falls below the value of 3 degrees Celsius, a red warning lamp is to come on, and an alarm from the TXT controller will need to sound once. In the second programming project, the model will be used as a mold detector or a mold monitor, where humidity is continuously measured. Here, the red warning light must be illuminated when the humidity is 80% or higher, indicating a danger of mold forming. In the third project, students will use the model as an air quality station. Now in this variation, students will need to program the model so that the lights are illuminated differently to indicate different levels of air quality, from very good to bad. Next up, students will work with a model of a stationary camera with the environmental sensor for data logging. The first project will involve programming this to act as a motion sensor or security camera, which causes an acoustic and visual alarm, in this case a sound from the TXT controller and the lighting of a lamp, to be triggered when motion is registered. The second exercise involves an introduction to simple data logging. Here, the values registered by the built-in brightness sensor are to be displayed graphically on an oscilloscope monitor in ROBO Pro. The third exercise with this model will involve logging the values collected in a spreadsheet program, where the data can then be displayed using, for example, a beam diagram. A fourth exercise will essentially combine the last two, where the data is both displayed on the oscilloscope in ROBO Pro, and at the same time the values are saved in a CSV file for graphic display in a spreadsheet. The fifth and final experiment with this model involves a flower vase with soil and a seed being placed in front of the camera. Students must then create a program to measure the temperature, humidity, atmospheric pressure, air quality, and brightness. These values are to be measured every 12 hours and saved in a CSV file, and each day a photo must also be taken to provide further visual information on the growth. Next up, students will construct a robotic barometer and program it so that the pointer on the model will point to a weather symbol, such as sun, clouds, rain, etc., corresponding to the current atmospheric pressure, depending upon the atmospheric pressure measured. The final model students will build with this set is a complete sensor station with a movable camera. This model will utilize various forms of data transmission, for example, connecting via the USB cable, an access point connection using wireless via the Wi-Fi computer to a TXT controller, or using the Wi-Fi client connection from the computer to a router to the TXT controller. The first programming project will involve using the model as a rotating surveillance camera, with the results viewable on a computer using the ROBO Pro software. Now, students will then learn how to connect the TXT controller to a PC using Wi-Fi. After this, they will learn how a Wi-Fi client connection can provide a greater range than a simple connection directly to the computer, depending, of course, upon the power of the router being used. The second project is an expansion of the first, where not only is the camera controlled, but the environmental data is also displayed on the oscilloscope. Now, as soon as the camera registers motion, an alarm is sounded. The next programming project involves learning how to connect the sensor station model to the cloud for the collected data to be displayed there. A special fischertechnik created website is accessed, where a dashboard monitor can display the various types of data collected from the environmental sensor, as well as the visuals from the camera. Students can learn how to control the camera itself from the dashboard monitor on this cloud-based site. Students see how they can control the model from anywhere around the globe using a smartphone, a tablet, or any PC with access to the fischertechnik cloud via the internet. And that's the Robotics Sensor Station IoT set. Now, once again, this set is available in two different versions. The first version, as you see over here, number 544625, like the last two sets we discussed, will require, of course, the ROBO Pro software, a Robotics TXT controller, and either a fischertechnik AccuSet or power set. So you either need to have all of those items previously or purchase them separately if you wanted to buy 544625. On the other hand, though, if you don't have any of those things, the easiest way to go about it is just get 544937, which is the complete set. It has everything you need, and of course, it'll save you some money. The prices on these, once again, the first set without all of the included the controller, software, etc., starts at $280 per set, or you can get the complete set starting at just $679 per set. The next item could almost be considered a standalone item in the fischertechnik education family. And this is the fischertechnik 3D printer set, item number 536624. Now, with this set, students can build an actual working 3D printer using the fischertechnik system. Now, please note that unlike many of the sets we have looked at previously, which could be used in a middle school setting or above, the 3D printer set is specifically designed for use by students 14 years of age or older. So essentially what we're looking at here is a high school age and above set. The set is designed to teach students the basic principles of 3D printing, which is also known as either additive fabrication or additive manufacturing. The activity materials created for this set, which are downloadable from the fischertechnik e-learning portal, begin with some basic information on the origins of this process, which has its roots in the work of an American inventor, Charles Hall, who is credited as the originator of stereolithography back in 1980. This precursor to modern 3D printing was a process where light-sensitive plastic is cured by a UV laser. Further developments in the field were made by people such as Hideo Kodama, Carl Deckard, and others, whose work was vital in creating the industrial 3D printing which we now know today. Scott Crump's experiments with glue guns during this period, which lead to the birth of the FDM process, also known as fused deposition modeling, are also touched upon. Next, we move on to an overview of the main components of a 3D printer and how they play a part in the process. And this begins with the extruder, then the printing nozzle, the printing bed, the limit switch, the 3D controller, which it should be noted is a controller designed especially for use with this set. It's not an item that's available otherwise, and the material transport. Instructions on installing the print drivers and software on your Windows-based PC, once again this will be versions 7, 8, and 10, are included next, as well as important tips on printer settings. The importance of calibrating the printing head and printing bed is also stressed. The adjusting of the Z-axis, which is a vital part of this calibration process, is clearly spelled out. The steps involved with the loading and exchanging of the filament, which is of course the material from which the objects will be printed, is also clearly detailed. At this point, students will actually get to print an object using a sample file provided. The file provided is in G-code format, one of the languages used for 3D printing or additive manufacturing. Now, once the file is completed, students also learn the process of safely removing items from the print bed. A sample from another file format, an STL file, or stereolithographic CAD file native to software created by the company 3D Systems, is worked with next. Students learn how such files must be prepared prior to the printing process with a slicer. And what a slicer does is it divides the object into thin slices, then saves these slices as G-code. At this point, the tutorial material provides a little more background on the three primary 3D printing processes which currently exist. Those three processes being FDM, or fused deposition modeling, which is also known as FFF, fused filament fabrication. And this is the process used by the fischertechnik 3D printer. We also get into SLS, which is selective laser sintering, and SLA, as we mentioned before, stereolithography. Now, the differences and advantages of each process are both briefly discussed. The instructional material then finishes up with an explanation on the differences in the G-code and STL file formats, a discussion of the PLA material, or filament, which is used for printing, and it also discusses sources on the internet for finding additional model templates to work with, as well as an overview of some of the types of design software for 3D printing. These are going to be things such as Tinkercad and SketchUp Make. And this is followed by an overview of safety tips for working with the printer, as well as troubleshooting and maintenance information. Again, the fischertechnik 3D printer contains everything needed to get started, and in this case that includes the controller, the power supply, the software, as well as a full-color 44-page assembly manual and sample filament. Additional filament, of course, can be purchased separately as needed, and the starting price on this set is just $830 per set. And once again, quantity discount pricing is available if you contact us. And that completes an overview of the fischertechnik robotics line. Now we're going to move on to the line of fischertechnik industrial simulation and training models. Now, the line of industrial simulation and training models differ from other fischertechnik products because they are not sets consisting of parts where the end user or student needs to build something, but instead these are all pre-assembled models mounted on a wooden base. Now, these are designed for use in colleges and universities, and also for training in companies and vocational schools. Besides this, they are also widely used by many companies for exploring and demonstrating IoT, for product and software development, for logistics and production planning, and for understanding automation systems. Each model in the current line of simulation and training models is available in two different versions. There are 9-volt versions, which are most commonly used in an academic setting. Now, these models come pre-wired to fischertechnik Robotics TXT controllers. These controllers have also been pre-programmed using the fischertechnik ROBO Pro software. Now, with the addition of a basic 9-volt power adapter, such as the fischertechnik Power Set or another power adapter of your own choice, the models are essentially ready to use out of the box. What I mean by this is unpack them, connect the TXT controller to a power source, turn it on, and hit the start button. There's also downloadable activity material with more information on the components, which again can be accessed from the fischertechnik e-learning portal using the code that's provided with the models. Now, besides the 9-volt version, there are also 24-volt versions of each of these models, which will be most commonly used in industry or for higher level technical and vocational training. Now, these contain 24-volt versions of the components, such as things like the encoder motors. It's a special 24-volt version of the encoder motor that's used. It's a 24-volt version of the S motor, 24-volt version of the compressors, the lamps, the solenoid valves, and so on. Now, these models, I should point out, will also require a standard industrial PLC, which is a programmable logic controller, such as is manufactured by companies like Siemens, Allen Bradley, Hitachi, Mitsubishi, and so on, for all control. As such, there is no programming supplied with these versions, with the 24-volt versions, and the creation of all the programming needed is going to be the responsibility of the end user. But I will say that as with the 9-volt versions, there is also downloadable activity material available on the fischertechnik e-learning portal. We'll begin with a look at the 5 newest models in the simulation and training line. The first is the vacuum gripper robot. And you'll see there are 2 part numbers up there. Part number 536625 is the 9-volt version, which comes wired to a pre-programmed fischertechnik's Robotics TXT Controller. Or you can get part number 536630, which is the 24-volt version, which requires, once again, a common PLC. Now, this model is essentially a 3-axis robot with a vacuum gripper, which can quickly and precisely position workpieces in three-dimensional space. And of course, you saw a variation of this when we were looking at the robotics and industry set. The next model that's available is an automated high bay warehouse, which is item number 536626. That's the 9-volt version, and that once again comes wired to a pre-programmed Robotics TXT controller, and part number 536631, which is the 24-volt version for use with an industrial PLC. And just because I'm catching myself here, I'm going a little bit off script. The vacuum gripper robot was not included in the robotics and industry set. There's the later version we're going to see. This is unique. Sorry about that. Anyway, going back to the high bay warehouse, as I said, there's a 9-volt version and a 24-volt version. And this model acts as a simulation, essentially, of a storage system such as you would find in many warehouses. It has a transfer station with a conveyor belt and a shelf stacker for storing and retrieving special workpiece carriers for the 9 storage bins. The third set of models in this progression is the multi-processing station with oven. Part number 536627 is the 9-volt version, which in this case is wired to 2 Robotics TXT controllers. That being said, only 1 power supply is required because of the way they're wired together. And again, part number 536632 is the 24-volt version for use with industrial PLC. And what this model does is it simulates a furnace with a pneumatic sliding door. The downstream processing station with a pneumatic transfer unit includes a vacuum gripper, a cutter simulation, a rotary table, and a conveyor belt. After this, we have the sorting line with color detection. Part number 536628 is the 9-volt version, pre-wired to 1 Robotics TXT controller. And part number 536633 is the 24-volt version, again requiring an industrial PLC. And this unit is designed to detect workpieces of different colors and sort them via conveyor belt into the designated storage slot. The final version of the 5 newest models is the factory simulation, which essentially integrates the previous 4 models, which being the vacuum gripper, the high bay warehouse, the multi-processing station with oven, and the sorting line with color detection. It integrates those 4 robots into one self-contained material cycle. Part number 536629 is the 9-volt version, which is wired to 5 fischertechnik robotic TXT controllers and will require 3 separate power supplies. Part number 536634 is the 24-volt version, again for use with industrial PLC. I will point out here that this model is in very high demand right now, and sometimes we will have a lag time for fulfillment of 2 to 3 weeks. Also, due to the dimensions of the pre-assembled model here, this model, if ordered, needs to be pallets shipped, so keep that in mind. The other 4 models currently available are older classic models in the simulation line. The 3D robot, again available in both 9-volt and 24-volt versions, is a 3-axis robot with gripping forceps used to quickly and precisely position workpieces in 3-dimensional space. This is the one that is essentially a version of what we saw with the Robotics and Industry set. The conveyor belt is a simple transport belt, 275 millimeters in length, used for transporting workpieces with a diameter of up to 29 millimeters. These conveyor belts can easily be connected to one another if needed. Once again, this is available in both 9-volt and 24-volt versions. The punching machine with conveyor belt, like the name says, simulates the movement and punching of various workpieces. And the last of the models available is the indexed line with 2 machining stations. This is a conveyor line with both a milling station and a drilling station simulation, as well as 4 conveyor belts in a U-shaped arrangement. Once again, this is available in both a 9-volt version, pre-wired in this case to 2 Robotics TXT controllers, and a 24-volt version, which again requires an industrial PLC. And that's an overview of the current line of industrial simulation and training models. Now, before we conclude for the day, I do want to touch very briefly on the other 2 sets, each of which is covered in their own webinar. Now, the reason each of these sets has a webinar is that each of these sets comes with extensive, highly detailed, standards-based curriculum for essentially offering what could be a standalone robotics or STEM class or a long-term after-school activity. Now, that being said, while each set is designed for conducting a curriculum-based program, they also serve as great all-in-one bundles of some of the most popular fischertechnik robotics sets, which we've already discussed, which with everything you need to build a large group of models, from the parts to the controller, the software and the power supply, everything else you need, all in one box. So even if you don't want to conduct a curriculum-based program per se, if you want to do your own program, but you'd like to have some of the options that we've looked at earlier in this webinar, this will give you a nice affordable way to do that and make sure you don't miss anything. Now, the first of these 2 sets is the fischertechnik Robotics Competition set. This curriculum-based set is designed to provide a pathway for exploring the subjects of robotics and coding through the focus on having students create mobile robotics of the type which can be used in a competition setting, whether at the local school level or even a larger scale national, international competitions, things like, for example, RoboCup Junior. Now, this set is designed around standards-based curriculum consisting of approximately 70-plus academic hours of material. Each set contains 670 parts and components, all packaged like the other sets we've discussed today in a sturdy Gratnell storage box. And when using the curriculum, this set is designed for use by small teams of 2 to 4 students at a time. And again, if you would like to know more about the specifics of what this set addresses, I invite you to attend the webinar which goes over all of that in detail. But for today, I want you to consider the fact that this can be thought of as the ultimate fischertechnik mobile robotics set. This one set will provide you with all of the parts needed to build the models in both the Robotics Advanced set, which we discussed earlier, as well as a retail set called the ROBO TXT Explorer set, which focuses only on mobile robots, along with everything else you'll need, of course. So you get the TXT Controller, the ROBO Pro Software, and the Accu-set for powering the models. 20 different models in all can be built with this one set, and again, everything needed is right in the box. And as you see on the screen there, your pricing here starts at just $699 per set. And again, quantity discount pricing is, of course, available. And the final set we're going to look at today is the fischertechnik STEM Engineering set, the contents of which you see right on your screen right now. The curriculum for this set is designed to provide a comprehensive overview of robotics, coding, and automation systems. Excuse me a second. Now, once again, it's designed to provide a comprehensive overview of robotics, coding, and automation systems. In short, what we're referring to here is mechatronics. Now, like the previous set, this is designed to be used by groups of 2 to 4 students in a classroom setting. It contains 890 parts in all, including, of course, the ROBO Pro Software, the Robotics TXT Controller, and the Accu-set, once again packed in a sturdy Gratnell storage box. The standards-based curriculum, which again is targeted at a high school class level, has a series of project-themed units, and these cover the areas of sketching and documentation, basic electricity, programming, sensing and vision systems, mobile robotics, actuators, and the fundamentals of automation and robotics. Now, the curriculum for this set is designed to provide enough academic material to cover over 150 academic hours. Essentially, this provides teachers with enough material to offer a standard 50-minute class period focused on STEM and robotics 5 days a week for a full academic year. And again, if you would like to know more about this set, the standards addressed, and the way the material is approached, and so on, I, of course, invite you to attend our webinar focused on project-based learning. For today, though, what I would like you to take away is that this one set, besides containing the curriculum I just mentioned, also contains all of the parts and all of the instructions needed to build all 22 models from the 3 sets we reviewed earlier, the Robotics TXT Advanced set, the Robotics and Electro-Pneumatic set, and the Robotics and Industry set. All of those parts, all those components are included here. So once again, this can be thought of as a great all-in-one option for obtaining everything you'll need in one box at a special price, even if you choose not to use the included curriculum for whatever reason. And here, the pricing starts at just $9.39 per set, and again, quantity discount pricing is available. So we've covered quite a lot of material here, and I thank you all for your patience and attention for sticking with us this far. And now, as promised, what I'm going to do is I'm going to open up the floor for questions. And basically, to ask a question, you can do a couple things here. You can either type in the chat window, which is located in the Join Me toolbar. It's the second icon, the one that looks kind of like a word balloon you would have seen in the old comic books. Once I open up the line, you'll be able to speak in real time with me. Or you can email any questions you might have to my personal email address over here at Studica. That's lancez@studica.com. So on that note, let me open up the line.
Only the host can talk now. Everyone can talk now.
Okay, if anyone has any questions, feel free to shoot them out. Okay, going once, going twice. And at this point, I'd like to thank you once again for taking the time to attend today. For more information, if you'd like to request a quote or if you'd like to speak with one of our dedicated educational representatives, you can simply call us at Studica US, 888-561-7521, or you can visit us on the web, www.studica.com/fischertechnik-education, or you can email us, or you can email me directly at either of the 2 email addresses you see on the screen, info@studica.com or lancez@studica.com. On that note, I would like to thank you all for taking the time to attend today, and we look forward to hearing from you. Have a great afternoon.